This lesson is on section 10.8 titled Roots of Monomials. So I'm going to first talk about this property and then hopefully make a little bit more sense of it using some examples at the bottom. So for any numbers A and B, so any numbers, we're just going to call them A and B in this case, where A is greater or equal to 0 and B is greater or equal to 0, then the square root of the product of AB is equal to the product of each square root. So if I'm going to square root any two numbers that are being multiplied together, all I can do, and what this property says, is I can kind of break these two numbers up. So I can say, kind of put a line down the middle, I can break them up and say the square root of A times the square root of B. So I'm just taking this number and I'm squaring it, and I'm square rooting it, and then I'm taking this number and I'm square rooting it so I can break it apart. So that's what this property says here. Okay, I can just take those two numbers, break them apart, and multiply their square roots. Also, we have another property here where it says if we're going to square root x squared, so what we can do is we can rewrite x squared as x times x. So that's all I did. I went from the square root of x squared equals the square root of x times x because I'm just writing the x twice. And then, or you can think about it is the square root and the square kind of cancel each other out. I'll talk about that in a second. So since x represents an unknown value, the absolute value sign is used to indicate the positive value of x. So what we can think about is, okay, well, if the square root cancels out the square, so then we're just left with x, and then we're going to put these two absolute value signs in there just to say that x is positive. So the square root of x squared equals x. Think about the square root sign and the squared sign cancel each other out, and we're just left with the absolute value of x. Kind of same thing with x to the fourth power, the square root of that right here. So we're just breaking x to the fourth power into x squared times x squared. Or we can think about it as, okay, well, this square root sign cancels out one of these, so we're just left with x squared. And because this is x squared, we don't have to put any absolute value sign on it because that squared already tells us that, that it's going to be a positive value. So we're going to take this, I know this can be confusing, we're going to take this and we're going to apply it to some examples here. So this first example says we're going to simplify. We're not going to, get an answer from here, but we're just simplifying the square root of 4y squared, or to the second power. So what I'm first going to do is I'm going to separate the expression. Okay, so using that property we just talked about, I'm going to say, okay, well, I'm going to separate that to the square root of 4 times the square root of y squared. So I just literally took and I separated this value and this value. Then, what I'm going to do is I'm going to simplify it from here. Okay, well, I know the square root of 4. I'm going to think of what two numbers multiply to make 4. Okay, well, I know the square root of 4 is 2. Okay, so again, the square root, you have to think about what two numbers multiply to make that number. Okay, well, I can break up the square root of y squared. Well, I know that, let's make this easy. We can do it this one of two ways. I'll do both ways. So I could say, well, this is the square root of y times y. Okay, and I know, we know from the property that this just equals y here. Or the way I kind of like it, and I'm going to erase this, is I know that the square root cancels out the square. These two kind of cancel each other out. So all I'm left with is y. And we have to signify that it's a positive value, so we have to put the absolute value signs on it. So all I'm left with is 2 times the absolute value of y. You don't have to put the multiplication sign in there, but you can. Okay, so let's try the next example. So it says simplify the square root of 36 q to the 6th power. All right, so let's start off. Let's just separate my values here. I'm going to say the square root of 36 times the square root of q to the 6th power. Again, I just separated the the two different values, put a multiplication sign in between. Okay, so now I'm going to say what two numbers multiply to make 36. So the square root means, again, what two numbers multiply to make the number under the square root. Well, I know 6 times 6 equals 36, so I can just simplify that to make 6. Now, square root of q to the 6th power. Well, this is a little trickier because we have the 6th power here. So I know, thinking back to my last chapters, so what we can do is we can put square root, and I know what two numbers, two of the same numbers to add to make 6. So I can break this up into q to the 3rd power times q to the 3rd power. Again, because 3 plus 3 equals 6. That's how I can break that up. Don't do 3 times 2. Remember, that's not the property. So again, you have to add those two numbers to make 6. So I broke that up there. So now, because of the property, we know that you can kind of think of like this and this cancel each other out, leaving q to the 3rd power left. So now we're left with 6 q to the 3rd, and again, we're going to put that absolute value sign here. And that's my final answer. Again, this is a little tricky, but let's keep referring back to my examples here when solving your homework or any other worksheets that you're doing. We'll have a lot of practice with this. And finally, we're going to talk about the product property of square roots. Okay, so for any numbers a and b, the cube root, so again, we're not talking about square root this time, we're talking about the cube root of the product a and b is equal to the product of each cube root. So if you notice the difference between this example and the last examples, we have the 3 here. Okay, that signifies that it's a cube root, not a square root. Okay, so let's look. The cube root of 216. Okay, so before let's look at this, let's think about what cube roots mean. Okay, so let's back up. We can say, well, 2 to the 3rd power, for example. 2 times 2 is 4, 4 times 2 is 8. So cube root is kind of working backwards. So what we can think about it is the cube root of 8 equals 2. Let's do another example here. Let's say we can say 3 to the 3rd power. Okay, 3 times 3 is 9, 9 times 3 is 27. Well, 3 to the 3rd is 27, so if we take the cube root of 27 equals 3. So you can think of what number multiplied 3 times by itself is going to equal that number inside that cube root. Okay, so let's kind of back up a little bit here. So now what we're going to do is we're going to take this number 216 that's inside my cube root, and we have to think about what two numbers that I can break that 216 into two numbers whose product equals 216. And the two numbers that we break it in have to be a cube root. So for example, I'm going to break 216 into the number 8 and 27 because 8 times 27 equals 216. The reason I chose 8 and 27 is because I know 2 to the 3rd power equals 8, kind of like this example here. And I know that 3 to the 3rd power equals 27. So I know that those are kind of, you can call it like perfect cube roots. So then from here I can say, I can work backwards. I can say, all right, what to the 3rd power is going to equal 8? Well, 2 to the 3rd power is going to equal 8. And I can say, what to the 3rd power is going to equal 27? Well, 3 to the 3rd power will equal 27. Or we're just working backwards. What's the cube root of 8 is 2. The cube root of 27 is 3. And then I'm going to multiply 2 times 3 to make my final answer is 6. All right, so let's do an example here. Okay, so I'm going to simplify. What's the cube root of c to the 3rd power? What's really nice about this one is all these numbers do is cancel each other out. So this 3rd power and this 3rd cube root cancel each other out, leaving c by itself. So that's it. Pretty easy there. Just kind of like square roots, And so, for example, the last example we had the square root of like c to the second power. Well, we talked about the square root and the squares cancel each other out. Same thing with the cube root and cube or to the third power cancel each other out. Okay, so the next example says, what's the cube root of 64 times g to the sixth power? So just like we've done before, let's separate these out. So we have the cube root of 64 times the cube root of g to the sixth power. Okay, so we're going to think about what number to the third power is going to get us 64. Well, think about this a little bit. Well, I know 4 to the third power equals 64, because 4 times 4 times 4 is going to equal 64. Hopefully, the more practice you get with roots, you can kind of start memorizing these. You can also use your calculator if you need to help you. So we can put 4 here. We can simplify that, because 4 to the third power equals 64. And then, if we kind of rewrite, well, g to the sixth power is we're just taking g squared 3 times. Oh, there's a multiplication sign, kind of messy there, because 2 plus 2 plus 2 is 6. Okay, and so from here, because this is listed kind of 3 times, okay, these are listed 3 times, so all this simplifies into is g to the second power. Kind of like we had before. So in our last example, we had, for example, like the square root of g squared times g squared. Well, because this is the square root is technically, there's like a little 2 there. We never put that there. But because these are listed twice, we can really just cancel this out to make it just g squared. So hopefully you're kind of seeing a pattern there. So finally, for my final answer for here, we're just going to make it 4g to the second power, or 4 times g to the second power. All right, this is one of the longer videos. I appreciate you guys sitting here and watching this. Again, this is a lesson that you're going to have to go back, check your book, check your notes, keep watching this video. You might have to watch it again to really look at the properties of these powers and how to simplify these expressions. Thanks for watching.